presentations. So when we get there, hopefully we will do that together too. So take note. This week we are supposed to do Unit 1 as usual. So that's basically what we're going to start, just zooming right into it. And before that, as I said earlier, this is going to be a 3-hour course. And so by convention, we are supposed to, decide on a day where we can have the extra 1 hour. Yes. So we'll have 2 hours today, and then we'll decide on a day to have the extra 1 hour. So I would entreat you that at the end of this class today, kindly think through your schedule and then let's decide on a date that we'll meet to take the 1 hour up so that we'll clear that. Madam Charity, any issue? Okay, thank you. Madam Abuna Gifty, your hand is up.
Sir, actually, our schedule is full. We only have Saturdays and Sundays.
You only have Saturdays and Sundays?
Yes. From Monday to Friday has been scheduled. It's very full.
Abner Sunday is also occupied though. The introduction to molecular genetics.
Hey, wait, is it the same Anita Frimpong that I know, Madam Anita that I know?
Yes, sir.
Hey, Madam Anita, what are you doing here again?
I'm here again.
What are you doing? What are you doing here? What are you doing here again?
I'm learning again.
Hey, you took the same course last year?
No, we didn't. We were not able to take it.
Okay, so you took science, nature of science, right?
Yes, we took nature of science. So we are now taking the science, technology, and society.
Yeah, that's why I see some familiar faces.
Yeah.
Especially you, I will never forget your voice. You know. It's nice.
I think it's lovely. Oh, it's nice having you as well. Thank you so much.
So what day should we decide on? This is it's open to the whole class.
Even Saturday is also packed because Saturday some of us have lectures from 7 to 6 in the evening. So you don't know what to do.
Please, kindly know what to do.
Sir.
Yeah. Kindly know what to do. Mr. George, your hand is up. Any suggestions?
Yeah, I suggest Tuesday 8 to 9 after the supplementary one. That is, I think, after development of science teaching materials, we can continue from 8 to 9.
Okay.
That's not bad.
Okay, that is okay with me if the whole class agrees. So
it's okay, sir.
So you said Tuesday, right?
Yes, sir.
Tuesday 8 to 9. Okay. If the whole class agrees, I don't have any issue with that. I would definitely make time. Okay. So I think it's a consensus of the class that we meet on Tuesday 8 to 9. All right. So please kindly add that to your schedules, and then we'll meet Tuesday. All right. Thank you very much. Okay, so we can start. So as I said, this is science, technology, and society. I think the name of the course even says what we are going to talk about. We're going to talk about science, scientific knowledge, how it is being utilized through technology, and how beneficial it becomes to the society in which we live in. So we're going to basically treat Unit 1 today. Hopefully, we'll finish. And so these are our objectives for Unit 1. And please, everything in the slide is directly taken from the course model. So those who knows that I don't normally share my slides. So, but you can take notes as we go along, but everything is in the course model. So kindly visit the course model for any references that you need. Okay, this is just to guide us through our class. Thank you. So we're going to start with Unit 1, and this will be our objectives for Unit 1. We'll talk a bit of about science. We'll look at technology, the types of technology that we have. We'll look at society. We will look at differences between growth and development. We should be able to also describe factors that influence social development, and we'll look at that in terms of science and technology. And then we will describe the influence of science and technology on economic development. So this will be our objectives for Unit 1. So as we go along, kindly mark yourselves whether we are achieving the objectives or not. So we'll zoom in quickly. This is a general question that I always ask. What is science? Let's take it from our perspectives, not from the ones in the book or the model. Okay, so class, what is science? At least this is not the first time we are treating science, so we have an idea about what science is. So please, what is science? It's open to the whole class. Just put up your hand and you'll be called to answer. What is science? Yes, Madam Gifty, your hand is up.
Please, as the process of obtaining knowledge through observation and then experimentation.
Okay, all right. Okay, thank you. Please, I want more. Please, I want more. This is not the first time we are doing science, so okay, Mr. Matthias.
Okay, so I think science is the acquisition of knowledge, like acquiring knowledge and then using it to better our lives. That's we apply the knowledge that we have in order to make life easier for us.
All right, okay, Madam Anita.
Okay, I would also put it that is a way of understanding the world through questioning, observing it, and also through experiments.
Okay. All right. Thank you very much. Yeah, so thank you for your response. And then you are all right. When we talk about science, the foundation of science is to acquire knowledge. And acquire knowledge about what? As Madam Anita said, we are acquiring knowledge about our world. We acquire knowledge about our surroundings. We acquire knowledge about the environment in which we live in. Okay? And how do we acquire this knowledge? The knowledge that is being acquired is done through systematic processes. That is what actually distinguishes science from other fields. The knowledge that science gains is obtained through systematic process. And so I know that in our elementary science, we did the scientific method, the method through which knowledge is being gained. We looked at identification of the process, the problem, what do you call it? Formulation of hypothesis, collecting data, observation, experimentation, analysis, conclusion. Okay, so these are the systematic processes that a scientist will go through in order to gain knowledge. All right, and the knowledge is being collected on the environment, on the society, in the world in which we live in. Okay, science seeks to just explain things around us. That is what science seeks to do. We are not talking about anything abstract or anything that we've not seen. It is the things that surround us that science seeks to explain. And so that is what sometimes makes science practical. And that's what gives science opportunity to really relate well with society. Okay, so I know that sometimes we feel science is so abstract. No, science is not abstract. Everything that science explains or tries to say exists around us. Atoms exist around us. Molecules exist around us. The elements that we talk about, they exist around us. Forces, they are all there. The only thing science is doing is just to explain to us what these things are, why they are there, and what they are there for. Okay, so please let's not try to think about science in an abstract way. All right. So just as you said, science is the accumulation of knowledge derived through these processes that you mentioned: experimentation, observation, and analysis. Before any scientist will come up with anything, that scientist should have gone through these systematic processes before we can accept that whatever he or she is bringing out is true. Without these systematic processes, we don't accept anything from anyone as being scientific. All right. And one will ask, what is the essence or what is the usefulness of the knowledge that we gain from science? The knowledge that we get from science, what is it used for? Okay. One, it is used to explain things that happens in our everyday life. As I said, science explains whatever goes on around us. Okay, so the scientific knowledge that we gain is used to explain everything that goes on around us in our daily life. It is used to describe events. There are a lot of events that through science we've been able to explain. Through science, we know why rain falls, we know why the sun is shining, we know the components of the sun, we know the solar system's eclipse, why they occur. We know why sometimes the moon is missing and sometimes it comes in the full moon. We know why earthquakes occur. We know a lot of things. All right. And so science or the scientific knowledge is also used to explain events that occur around us. You understand? It's also to diagnose the conditions, nature of conditions, most especially when you go to the hospitals. Okay, scientific knowledge is used as a means of diagnosis. Okay, through that they're able to diagnose, to identify what is wrong with patients when they come there. You understand? And so all these things are too social, right? They are too social. There are things that occurs around us, and so there's no need to think too abstractly of science. All right, so science throws more light on things that already exist in nature. There's nothing abstract about science. So please let's draw away from that mentality that science is too abstract. It's very, very social, and then we use it in our everyday life. Okay. Now, before any body of knowledge can be accepted as scientific, there are some characteristics that that body of knowledge should portray. There are characteristics of knowledge that that body should portray. Generally, we say that to be a scientist, okay, or the mode of thinking of a scientist is longitudinal and inventive. The mode of a scientist, or the thinking mode of a scientist, or the thought of a scientist is longitudinal and inventive. What do we mean by that? What do we mean when we say a scientist's mode of thought is longitudinal and inventive? What do we mean by that? Please, so I said we are all talking on, so don't. It's an open question, please. We are all answering. I'm not the only one talking. So, class, what do we mean to say when we say a scientist's mode of thought is longitudinal and inventive? Yes. And I'm waiting for your answer, please. What do we mean when we say a scientist's thoughts or mode of thinking, or the way scientists think is scientists think longitudinal and inventive? We are all scientists, so we should be able to say something. Mr. Michael.
Please, when we say science is then it's because it studies phenomena over time, and then it tracks changes, and then development, and then probably long-term effects rather than capturing a single moment.
Okay. All right. Thank you. Please, any other contribution? Any other contribution? Any other contribution? Any other contribution?
Okay, sir.
Yeah.
With the inventive side, I'll say it means scientists are like they are creative.
Okay.
They create things, and the longitudinal, maybe as years go by, they build on things. That's how I understand it.
Okay. All right. Thank you. So yes. So you are right. So when we say a scientist mode of thought or scientists think longitudinally, it means that they think across a period of time. Scientists don't think in a present moment. Okay. So scientists normally refrain from asking questions like, what is happening now? No. A scientist will never think like that or ask such questions. Their questions are in series. Just as Mr. Edu Michael say, they think across events. They look at past events. They collect data from the past. Okay. And then they think through that period of time to make predictions in the future. So as scientists, we don't think in a present moment. No. There's no way a scientist will think in a present moment. Even if there are issues happening, a scientist will try and trace it back to the past, collect data, accumulate all the knowledge and data that they will need, analyze them, and then use it to predict whatever will happen or to explain whatever is happening currently. Okay, so scientists tend to think across extended periods, not just in the present moment. No. And when we say they are inventive, as Madam Anita said, they are very skillful. They are very skillful. And so, as a scientist, you should ask yourself, how is your thought process like? Yes, how is your thought process like? And are we being skillful in our daily life? Sometimes we want to isolate that to those in the industries. No, but as teachers too, we have to be longitudinal in our thoughts. Okay, we have to be longitudinal in our thought. And even in our assessment of our students, there are instances where you see that a student is struggling in his or her present moment, but then in order to help the student, you need to go back to check the records of the student. That is you being a scientist. But others will just rely on the present result of the student to just judge whether he or she is being good or not. Okay, so in our daily interactions with our students, we also exhibit this longitudinal mode of thinking. Okay, the only thing that I feel we have to add more is the being skillful, being inventive in our thoughts. Okay, so that is what we mean by scientists think longitudinal. They don't think at a present moment. They think over a long period of time before they can make, what do you call it, conclusions and bring out knowledge for us. Now, before a body of knowledge can be described as science, there should be certain characteristics about that body of knowledge. And we are very peculiar and then about these characteristics. We don't accept anything that do not meet this criteria. All right. So one, we say science is tentative. Science is tentative. Please, when we say science is tentative, what do we mean? What do we mean by science is tentative? Okay, Madam Abena. Madam Abena, we can't hear you. Hello, Madam Abena, we can't hear you. Okay, I think she's off. Yes. So please, science is tentative. What does it mean? What does it mean to say science is tentative? Okay, Mr. Matthias.
Okay, from my understanding, means that it is not static. Like it can change when new discoveries are made. So science is not static; it's dynamic. It changes.
Okay. All right. Thank you. Is it Sabomi? Sorry if I got your name wrong.
Yeah, that's Jacob.
Okay, Mr. Jacob. Sorry. Yes, let's hear you.
Yeah. So when we say science is tentative, it means that the knowledge of science is not something that is permanent, but as time
Mm-hmm.
goes on, there are bound to be changes in science.
Okay. Okay. All right. Please, one more, then continue. One more. What do you mean by science is tentative?
Sir,
Yes, Mr. Desmond.
so it means that when we say science is tentative, it means it evolves around evidence.
Okay. All right. Thank you. All right. Thank you all. So, okay. So, whatever you said is correct. When we say science is tentative, it means that it is provisional. When we say it is provisional, it means that it is not the final thing. It is not the final thing. For example, in mathematics, 1 plus 1 is 2. Okay, 1 plus 1 is 2, and that is the final answer. There's no way you can prove to me in mathematics that 1 plus 1 is 3 or is something else aside 2. No. However, when we come to science, 1 plus 1 can be 2 and it can be something else. We get it. So until a body of knowledge is proven beyond reasonable doubt that is the final answer, it is always tentative. There are a lot of concepts and principles, laws and theories in our scientific books that have been refuted over the years. Okay, so the fact that you bring a body of knowledge out doesn't mean that is final. No, scientific knowledge cannot be final. Every scientific knowledge is tentative and can be proven wrong. All right, so that is what we mean by tentative. It's not a final thing. It is provisional. Okay, it is provisional. Just as in some of our lives we say, well, these are the provisional results. It means that's not the final one. Okay, so scientific knowledge is dynamic, it's tentative, it's provisional, it's not the final thing. It can always be changed whenever the need arises. All right, so that is it. So any body of knowledge that is not tentative, it's not scientific. Let's follow that. Any body of knowledge that is not tentative, it's not scientific. All right. The second one is science is falsifiable. Science is falsifiable. What does it mean by that? What do we mean by that when we say science is falsifiable? Okay. Let me talk to Madam Charity. I've not heard her voice, so Madam Charity, let me hear your voice.
Yes, I said, please, falsifiable. I understand that
Yes.
it can be proven as a false with a hypothesis and other method to show that what somebody has brought is false. That's
Okay.
what I understand.
Okay. All right. Thank you. Thank you. Madam Anita, you wanted to say something?
Yeah, it's just similar to hers. As in the face of evidence, a scientific claim can be said to be false.
Okay.
So, for instance, when let's say they say all stones maybe probably float, and then you try to test it and see, and you realize that no, it doesn't float, then it means that claim has been falsified.
Okay. Okay. Well, thank you. Any other contribution?
Sir,
Yes, Mr. Desmond.
please, how I understand is means the theories of science, the scientific theories.
can be proven to test its whether it's true or false.
Okay. All right. Thank you. Mr. Yakubu, your hand was up.
Sir, that is what I was going to say. What he said is what I was going to say.
All right. So that is true. Let me say scientific knowledge is falsifiable. It means it can be proven wrong. Okay. And that also goes in line with the tentative nature of science. It's not the final thing. Please, just a second. All right, sorry about that. So it goes in line with the tentative nature of science. Science can be proven wrong. Okay, no matter who you are, you can be professor who, you can be professor this. You can bring a theory out, and within a second, a young person can falsify your theory. All right. So science can be proven wrong, or it can be proven to be false. So that is it. Thank you. And the second one, science is empirical. What does that mean? Science is empirical. Yes, someone should explain to us. Science, what do you mean by science is empirical? Okay, Mr. Evans.
Please, I think the empirical has to do with it is based on evidence that the person performing the experiment has brought out. Thank you.
Okay, thank you. Madam Helena, yes, let me hear your voice.
Okay, so the empirical has to do with the observable, meaning science can be observed. We can feel it, we can touch it.
Okay. All right, thank you.
Yeah. In terms
thank
of
you.
practical.
Okay, all right, thank you. Mr. Matthias.
Okay, I think that's what my sister said. That science is something that you should be able to observe and then also experiment on it. So you can
Okay.
have experimentation based on what by observing as well to get the knowledge of science.
Okay, all right, thank you. Thank you. Okay, yeah. So one of the things that I tell my students and my scientists is that as a scientist, you are neither wrong nor correct. And so in class, we apply the same principle. No contribution is wrong or correct. We are all just trying to share. So science is empirical means it is based on evidence. You can't just start talking like you want to talk without giving us evidence. In science, evidence matters. Okay, if you tell me that when I add tomatoes to oil, I'll get stew, you have to show us the evidence. Okay, you have to show us the evidence that adding tomatoes to oil will give you stew. So everything in science is based on evidence. In the last one, we say science can be tested. Yes, every scientific knowledge should be tested. If someone is in the US and comes out with a scientific knowledge that should be accepted all over, someone in Ghana should also be able to do the same thing, go through the same process and get the same result. If not the same result, very, very similar to that of the person in the US. So all scientific knowledge should be tested or should be able to be tested. Once you can't test it, it's not scientific knowledge. Okay, so these are the generic characteristics of science. Any other body of knowledge that not fall under this is not science. Okay, so sometimes they can give you some knowledge, and then they will just tell you to identify whether it's a science or not. So in your identification, you have to use these characteristics. First, you have to find out if it's tentative. Can it be falsified? Is there evidence attached to that body of knowledge? And can you test it? Once they fit into this criteria, you'll be accepted as science. All right. Thank you. Any questions so far? Any questions? All right. So yes. So without any further question, that brings us to the end of. All right, Mr. George.
Yeah, so my question has to do with science. The definition, when you compare the definition of science and technology, we understand that technology is the application of scientific knowledge to produce things for human use. And in science, we also apply certain things like application. So I just want you to explain further for me to understand the differences.
Okay, between science and technology, right?
Yeah.
Do you want the difference between science and technology?
Yeah, the differences between science and technology in terms of the definition.
Okay, all right. So, okay, thank you. So we've spoken about science, we've spoken about what science is. Now, we are going to talk about technology, okay? So let us finish with dealing with technology. And then after that, Mr. George, if you don't understand, then I will come in. Is that fair?
Yes, sir.
Okay, thank you. So we are now move on to technology in section 2. So after that, and then we just do the analysis ourselves, and then we just look at what we can get from that. Good, thank you. Yes, so the second session we look at technology. If we've done science, so we look at technology. I think Mr. George has already opened the lesson for us. Technology, application of scientific knowledge. Yes, this is very common. When we talk about technology, the simplest explanation we can give to technology is the application of scientific knowledge. Okay, the application of scientific knowledge. And this application of scientific knowledge is mainly to enhance productivity. It's mainly to what? To enhance productivity. And so there are a lot of instruments, there are a lot of tools and infrastructure that through technology we've gotten, and they've been very, very, very beneficial to us. Currently, we can't live our lives without these technologies. We can't live our lives without it. And one of the very, very, very common tools is our phones. We can't, no one, you can't live your life without your mobile phone. You can't. And so you see how addictive and very dependent technology is. All right. So we are talking about the application of scientific knowledge. Okay. So the knowledge is there. The knowledge is there. And that knowledge is science. That knowledge is science. Applying that knowledge to make resources, to make tools, to make infrastructure, equipment is technology. Okay, so we say it is the application of scientific knowledge to improve life. The core aim of technology is to improve life, to improve productivity. Okay, so in our model, it says that the essence of technology, the importance and reason of technology is to facilitate human life and aspirations, to solve practical problems. Okay, so I'm sure there was an issue with communication. That was why the phone was invented. There was also an issue with transportation. That is why cars and all those means of transportation was was invented. You understand? So the aim of technology is to solve practical problems, okay, and to positively utilize knowledge. What are we going to do with the scientific knowledge that we gain if we don't apply them? It will just be useless, okay. But the mere fact that we're able to utilize that scientific knowledge, okay, makes it very positive and very good. Okay, so technology is positively utilizing scientific knowledge that we gain. Okay. Okay. And when we compare the two again, one is the knowledge and one is application. Science is the knowledge and technology is application. Again, when you look at science, science just means to explain what already exists. Okay? When we talk about scientific knowledge, it is just to explain what already exists. But technology does the opposite. Technology brings into existence what has never existed. The mobile phone never existed. The cars never existed. You understand? So it was the duty of technology to bring into existence all these things. But science just talks about and tries to explain whatever exists. The solar system had existed even before man was created. All the principles, the gravitational force, all those principles in our scientific handouts had existed before man came, and they still exist. So science just took the opportunity to explain all these things that already exist. But technology brings a totally different thing, or things that have never existed before. All right. So that is also another difference between science and technology that we can look at. Yes. And so technology exists to serve humanity. We've reiterated that. Now, we saw that the mode of thinking of a scientist is longitudinal and inventive. It's longitudinal and inventive. Now, comparatively, the mode of a technologist is lateral. While the scientists think longitudinal, the technologist thinks lateral. What does it mean when we say a technologist thinks lateral, or the mode of thinking of a technologist is lateral? What does it mean? Yes, class, what does it mean?
Okay, let me. I don't. From my, does it mean maybe they are thinking about the problems that are existing now and so want to solve those problems?
Manito, I asked the question now, so it's
Okay,
like
so
you also
that
want
is
to
what
ask
I
me the same question.
Okay, let me still be thinking about it.
Okay, thank you. So what does it mean when we say the mode of thinking of a technologist is lateral? All right, Mr. Jacob.
Okay, so when we say the thought of a technology is lateral, what I understand is that for them, they think across like all areas. They don't base on one particular aspect, but their thoughts are always across everywhere, like around, all around.
Mm-hmm.
Yeah.
All right. Thank you. Let me be gender sensitive. Madam Charity. Then we go to Mr. George.
Okay. So I think it means that they think creatively. They think
Okay.
creatively, yes, sir.
All right. Thank you. Mr. George, your hand was up.
Okay. So I think the technologies are always moving about searching for new ideas. So their intention is to move forward the world, move the world forward.
Okay. All right. Thank you. Okay. Thank you all. So when we say as technologists think laterally, or the mode of thinking of a technologist is lateral, your contributions are all right. So when they think creatively, that is one. Technologists think lateral means they think creatively. And two means they think across all disciplines or all board. They think across all disciplines. They don't stick to just one theory or stick to one discipline. No. Okay. So a technologist will go to science, will pick a bit of that. We'll go to engineering, we'll pick a bit of that. We'll go to what do you call it? Psychology, we'll pick a bit of theory from there. We'll go to sociology, we'll pick a bit of that. We'll go to wherever they will have to get solutions to the problem, they will go. So they don't stick strictly to one. That, oh, I'm sticking strictly to mathematics to solve issues. No. A technologist doesn't think like that. He or she is always sticking around, looking for solutions around. So even if it's going to be linguistics, obviously they are going to do that. And I watched a video of how Apple produces their phones, and it was surprising that even the coding of language into the phone or into their equipment, there's a linguistic there's this language who is being consulted to go through that. And you would say that he or she is a science person. So what is the person doing there? No. Okay. They are thinking across. And I need to do a language programming onto my phone and my laptop. Who best can I consult than that person, though he or she is not a scientist? Okay, so that is how scientists they think. They don't go strictly to technologists. That's how they think. They don't stick to just one field and then use it to solve problems. They think otherwise. They think all around, and that is one way that a scientist can also adopt. I think yesterday I met your colleagues doing Nature of Science, and I told them that when you look at science education, it is not on its own. It borrows from, of course. So you have a bit of psychology in science education. You have a bit of sociology in science education. You have the rest in science education. All right. So that also cements the fact that we are also technologists in nature. And so we are also supposed to think across board. There are instances where they tell you that science they can't speak good English. That was what they were telling us. But that shouldn't also be the case. We should be able to, even though we are science students, we should also excel in the other courses or other services that we do. Okay, so that was just by the way. But that is who a technologist is. They think across board. They don't stick to just one field. And that is what actually distinguishes them from the other courses or other subject that has to do. Is any question? Any questions so far? So, Mr. George Sapon, right? So, your question that you asked,
Yes, sir.
did you have an
Yes,
answer
sir.
now?
Yes, I understand that technologies are higher in terms of knowledge and their application. I learned they are higher than scientists themselves, or I don't know if I understand it well.
Okay.
Like those who produce mobile phones. Can I say they have graduated from the science to a different level that they are able to produce mobile phone? Because you cannot produce mobile phone without having the basis of scientific ideas.
Okay. It's true that where your angle is also right. So you would probably say that technology is higher than science because of the fact that there's an application of the scientific knowledge. One of the things that you also have to understand is the fact that technology also depends on science. Without science, there's no technology. Okay, so they work hand in hand. No one is superior over the other, Sir George. No one is superior over the other. Okay?
Okay.
Yes. Science is the knowledge. And then applying the knowledge is technology. Okay. The same way any of them is useless without the other. That is how they do. They go hand in hand. One is the knowledge, one is the application. Okay. Is that George?
Okay, sir. So
All right. Mm-hmm.
the body of knowledge is there, and if you want to use it to produce something, then you become the technologist.
Yes.
Okay.
Yes.
But
And
some other people are also saying that those who
Mm-hmm.
produce mobile phone, because we don't, sometimes you wouldn't understand how come they produce some products, you don't understand it, but we are using it. Even if you're a scientist, you wouldn't understand how they produce it. So some are saying it is spiritual or something, or that's all, that they have spiritual backing.
Producing mobile phone is spiritual. That is funny. Wow, it is my first time hearing that producing mobile phone is spiritual.
Not really only mobile phone, but other products from technologies.
Yeah.
I learned we are saying we use technology products, but we don't understand them. I don't know how we explain it.
You see, there are a lot of, you see, when you pick the mobile phone, there are a lot of components in the mobile phones that it's just simple, what do you call it? Principles in science. You pick the screen. The screen is as a result of these electrons moving and hitting the screen. When you pick the cathode ray tube experiment of J.J. Thomson, where electrons were shot from an electron gun to hit a fluorescent screen, and then there is a glow on the screen. This is the same idea that we were using to, and then that idea has straight from the what do you call it, the LED. You understand, the fast screens, the batteries in the mobile phones. They work on what do you call it, the this principle, oxidation and then reduction reaction. That is what goes on in the batteries. Redox reaction, yes, in chemistry. The batteries that we use in mobile phones, the lithium batteries, they all work basically on the principle of redox reaction. Okay, the diodes and then the semiconductors in the phone, they are all principles in the books that we use. Okay, so someone will say it's magic. It's not magic. It's not spiritual. It's just people who have sat down and thought about these things and how to apply this knowledge. The fact that you can't apply doesn't mean that they are witches and wizards.
But sometimes they are saying that how to produce those components is what they are talking about. But the explanation is I think it's okay.
I do. I think when we I think undergrad, I think level 300, or when I was in school, we visited this man, Apostle Kujusafo Kantaka. Yes.
Yeah.
Yes. And he produces everything himself.
Yeah.
He produces, yes. And when we went there, we saw the process through which he produces the engine. And it was nice. It was so nice. So if you get opportunity to observe these things, then you realize that everything that these white people do, we can equally do some in Ghana. And it's just I said, it's just these basic principles that we learn. See, but because we are not able to apply them, that is what we think. It's magic. It's not magic, bro.
So how to apply them is where the problem lies. Because I
That's
don't
why
know
you're a
why.
teacher. That's why you're a teacher.
Okay. So
Yes.
we are praying that Ghana we will start producing electronic gadgets so that we also get the foreign exchange.
You can make a difference. You are a teacher. You are a teacher in
Yeah,
training. So it
yeah.
starts with you. When you go to the
Okay.
classroom, start teaching your students not just theory, but how they can apply the knowledge that they learn.
Okay, sir. Thank you, sir.
All right. Thank you too. Okay, so that is it. Application of scientific knowledge. And you see, that is one thing that we as teachers we should all try to what do you call it? To practice. The theory is too much. Yeah, the theory is too much. My dear teachers, the theory is too much. Okay, let's try to practicalize some of the things that we teach in our classrooms. Okay, I've in real life I've had a couple of experiences that I wish sometimes it is these theories that we learn to school that actually helps. Okay, and an example is on one of my business stores. I had issues with my plug, the equipment that I'm using for an event. I had an issue with the plug, and I needed to fix the plug. I searched around, I couldn't get an electrician to do that for me, a common plug. Oh. Then I remembered that in SHS, electricity, there's a topic in electricity called the plug, where we learned about the color coding of the wires and how to fix a plug. It was very theoretical. But at that instance, I needed that knowledge to fix the plug. And I didn't know how to do it. So I had to go online, check some videos, watch some videos, and check the color coding of the cable before I was able to fix it. And now I can do it effortlessly. You understand? So some of these things that we learn, some of these principles that we learn, they are not just theory. No, they're not just theory. You can apply them. There are some basic things, basic things in our lives that Charlie we will need. Okay. So those who did nature of science last year, we talked about arguments that enforces that everyone should understand science, should learn science. And you see the utilitarian argument says that at least everyone needs a bit of science to manage certain technologies that we encounter. Those who did nature of science, I know you should be able to recall that. So regardless of whoever you are, whatever you do, you should have a bit of science, the practical aspect of science. So dear teachers, please, book and also too much. Let's learn to practicalize the science that we teach. Mr. Fuseni, your hand was up. Okay. Yeah, so we move on to that was just by the way though. So that's technology. Now let's move on to the types of technology that we have. The types of technology that we have. There are basically two types. We have traditional technology and then intermediate technology. So please, you pick one and you explain to us. Yes, you put up your hand and then you tell us which one you're explaining. Then you talk to us. Let's try and then have a conversation about this. So what are these two types of technologies that we have? The traditional technology and intermediate. What are they? And you give us examples too. Yes. So who is going first? Who's going first? Okay, Mr. Jacob. All right, Mr. Jacob, let's hear you.
Okay. So I will talk with the intermediate technology. So that one is the
Okay.
type of technology which is yes, yeah. So I'm talking about the intermediate technology. Yeah, so the intermediate
Okay.
technology, that one is the type which is more advanced than the traditional one that we use.
Okay.
Are you getting me, sir?
Yeah. Yeah. Yeah.
Hello.
Yeah.
Sir? So let me give an example.
Hello.
Like, you know, yeah.
Hello. Okay. I think Mr. Jacob is off. Please, who else has his hand up? I think someone had the hand up. Okay, Mr. Evans, let's hear you, please.
Okay, thank you. Please, I will take the traditional technology. And
Okay.
from my understanding, it has to do with the indigenous way of doing things in the past, where we use certain tools to help us work easier and faster. So my two examples will be in the maybe preparation of alcohol, where they set fire
Mm-hmm.
and then they connect tubes to the barrel, and then they
Mm-hmm.
are able to extract the alcohol from the palm wine, and they get water separate and then the alcohol.
Mm-hmm.
So that is the traditional one.
Okay.
And we can also look at way of farming, where they use cutlass, and then
Mm-hmm.
sometimes they use stick and cutlass going to the farm to go and work on the farm. So I think that is, in terms of technology, that
Mm-hmm.
is the traditional way of doing things. Thank you.
Okay. Thank you too. Any other contribution, please? Hello, any other contribution?
Okay, sir.
Okay.
So agreeing with the intermediate, I see it like with that, it's like bridging a gap between the traditional way of doing things, the traditional technology, and then the modern day of technology. So it's like developing the traditional things. So as he said, now we have
Mm-hmm.
these modern distilleries, which I think use or tap knowledge from the traditional distillery to modernize what they are doing today, bringing it to a much more enhanced way. Something like what else?
Okay.
Which example again? Yeah, so like developing new developments based on traditional technologies. I think that is how I
Okay.
understand.
All right. Thank you. Okay, Madam Charity.
Yes, sir. Please, with the traditional
Okay.
technology,
Let's hear you.
example, when we go to the farming side, at the northern side, you will see that some tools or equipment will be attached to an animal so that it will enhance their
Mm-hmm.
farming system for them to plow a quite large area within some short possible time. That is the traditional technology I know. But when it comes to the intermediate one, they will base on what they've seen in the traditional technology way and bring it into the modern way that it will be more faster and easier than the traditional way. So as the example I said that tools will be connected to animals, you see that they'll be using the
All
a
right.
tractor for plowing, which is more easier and
Okay.
faster as compared to the traditional way of using a boom. Thank you, sir.
Yeah. Yeah. All right. Thank you too. Yeah, so you're all right. You're all right. You're all right. So these are the two types of technologies that we have. The traditional technology is basically the old and outdated technologies that were used by our forefathers. Okay, and they have been passed on. Some of them have been passed on from generations to generation. And what surprises that some of them there hasn't been any modifications to that. And so that is those outdated technologies are what we call the traditional ones used by our forefathers. Okay. Sometimes when we talk about traditional technologies, we are just looking at the tools that our forefathers used. No, that is not the only thing that we can look at when we talk about traditional technology, not just the tools. Okay, the skills too also matter. The skills. Okay, so it's not just about the tools. We also have to look at the skills. Sometimes our grandparents will do something in the kitchen, and then you look at them, and then it's some way. Okay, and I know some of you also have your own experiences when it comes to that. Okay, so it's just like that. We can't also just look at the tools that they use, the equipment and everything. Traditional technology also looks at the skills aspect of those things too. And then they're also prominent in our in our rural areas. They are very prominent in our rural areas. Not to say that there is no what do you call it, enlightenment in our rural areas. No, some of these technologies are being passed on from generations to generation, and they form parts of the culture of that community or society. So they can't easily forgo it like that. Okay, you can't easily forgo it like that. So that is traditional technology. A lot of examples that we can actually give if we are to do that. A lot of examples we can give. And I know you give what do you call it? An example of that. I think Madam Charity was talking about the what do you call it? The cattle taxing. And then I think the hooves and then the cutlasses that we use, or we still use them though. We still use them. In our kitchens we have a lot of them. Okay, when you go to the villages, sorry, they still use this traditional method of cooking. Is it, what do you call it? Is it muchi or something? I don't even know the name. The one they use clay for. Yes. Yes, something like this. Okay, so these are all traditional examples of traditional. I still use the first one, the what do you call it? The earthenware, and then the earthenware masher. I don't think the blender can match this. If you want to eat banku with hot pepper, you can't use the blender for that. I don't know who. I don't like my.
You can use it.
It wouldn't taste the same. It wouldn't taste the same, please.
You will not use it so that it will be too smooth. You have a way to go about it.
Oh, but Anita, you're lying. You used to taste it like that.
It's not true. It's not true.
Okay, so
Please, sir, I have a question.
even in the cities. Okay, Madam Charity.
So my question is, comparing the olden days technology and then the recent technology that we are using, which one is more healthier, if I may ask?
This, the question is for the whole class. Which one is healthier? Comparing the what do you call it? the olden technology, the olden days, the technologies that they used to, and then now, which one is helpful?
Sir,
Let's discuss this.
Say
Okay.
it depends on the
sir, with
context
this
at
question,
which
you can't
it
judge
depends.
whether this one is healthier or not.
Yeah, it depends. Say.
Please hold on. Mhm. Who was talking first? Someone was on the line.
Say
Yes.
it's me, Thomas. It depends because
Okay, Mr. Thomas. Okay.
taking a look at let's take a look at grinding in the olden days and these are modern day grinding.
Mhm.
Looking at the olden day grinding, per what tradition taught us, our parents used to use rocks, and yeah, that is
Mm-hmm.
a flat stone and a spherical shaped stone to grind flour to stir tisset or banku or whatever they
Mm-hmm.
wanted to do.
Mm-hmm.
So that one, comparing it to this modern day grinding mill where you have to go and use machine and grind, I see the olden days want to be better because in the grinding, two metals rub against each other, and friction always causes tear and wear.
Mm-hmm.
So pieces of these metals are mixed in the
Mm-hmm.
flour we eat, so which has a
Mm-hmm.
long-term effect on our bodies as we keep on using it compared
Okay.
to using the normal grinding stone they use at their time. But there are
Okay.
instances where
Okay. So that.
modern technology too
Mm-hmm.
is far like advanced or better than that of indigenous.
Okay. Okay. So that is the perception. That's the viewpoint of Mr. Thomas. Okay. Mr. Jacob.
Sir. Okay,
Yes.
so to the question he asks, the traditional technology is more healthier than the intermediate one or the modern one we call. In the sense that just as my
Mm-hmm.
brother and they said, there are a lot of health hazards that come with using the modern way or the modern technology. But as compared to the traditional one,
Mm-hmm.
the health hazards are very less. So talking of the one that is more healthier,
Mm-hmm.
it is the traditional one. It's just that the intermediate one is faster. It poses a lot of risks to us.
Okay. Mm-hmm. Okay. Okay. Um. any other contribution?
But sir,
They are all saying it is.
yes, sir.
Yes, sir.
Sir, in terms of water
Yeah.
preservation,
Go ahead, please.
you can't say the olden ways of preserving water is better than
Mm-hmm.
nowadays the way we used to preserve treat water and then use water. So it depends. It depends on the area that we are talking about. Because nowadays we distill water, we have purified water through the best method of distillation.
Mm-hmm.
We have so many types of bottled waters that we drink, and this one I think is better than
Mm-hmm.
and in the olden days that they were using the mud pot in preserving water without no treatment, and then there were so many kinds of disease. So it depends on what you are talking about.
Okay. 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 Thank you, Mr. Bernard.
I think the traditional one is better than the current one because looking at even the full pounding machine now that we are using as compared to the modern and so you see that Since the traditional one is far healthier than the one that we are using now. Thank you.
Yeah, all right. Sorry about that. Network issues. Okay, so please, where were we? I think Mr. Bernard was speaking.
Yes, sir. Sir,
Oh, yeah, Mr. Bernard.
sir,
So
I
please go
said that
ahead.
the traditional. I said the traditional technology is healthier than
Mm-hmm.
the intermediate or the current that we are using now. Because when we look at the thing that we were using at olden days as compared to now, the
Mm-hmm.
now the current one that we're using is faster. But if we
Mm-hmm.
look at the healthier wise, the traditional one is far healthier than this current one that we are using. Even the fufu machine that I said. Now everybody
Mm-hmm.
want to go and pound using that machine. But at olden days, we were using the mortar and pestle. Even when the tester self is better than now that we are using the fufu pounding machine that we are using now.
Okay, okay, that's cool. Mr. Matthias.
Okay, I also want to say that for it being healthier or not, it depends on you, the person using the technology.
Mm-hmm.
I don't know if you have chance upon these Indian street food
Mm-hmm.
that they've been selling. You see, they are using the traditional way
Mm-hmm.
to prepare the food. They are using their hands and everything. But the moment you see it, you know this thing is unhygienic.
Mm-hmm.
So even though it is a traditional way that they are using the traditional technology they are using, but you see, you just look at the environment, the condition in which they are making the thing, and this you can see that this is not healthy. It's not good for your health. So it doesn't matter. It's like what actually matters is you, the person using the technology. If you are, it's not all the modern technology that has this. For instance, one of my colleague said, when you are grinding, the friction is going to cause the wearing of the metal into your food. What of the
Mm-hmm.
one that does not involve wearing of metal? For instance, this fufu pounding machine that you are talking about, it's not the grinding type that we all know. Maybe
Mm-hmm.
smooth surfaces coming together to grind it. So it depends on you, the person using the technology,
Mm-hmm.
you adhering to safety precautions. If you want to look at the modern ones, for instance, it is not. It is rare to say that someone has pounded your fingers because you were pounding fufu. Yes. So it's not. We cannot say this is better. This is, but with the modern one, what I know is that the modern has made using technology easier and life has become easier. But with the olden one, you go through a lot. So with the health condition, I think it depends on you the person using it. Thank you.
Okay. All right. Madam Anita, I think we'll take Madam Anita on. We'll move on.
Okay. So as well said by him, you can either say traditional or intermediate is better. But let's take for instance, in the olden days, we are basing it only around fufu machine, the grinding, the earthenware and all that. But let's take the firewood usage as well. There is smoke coming out there. We have people may suffer eye conditions, respiratory diseases and all that. But now we have safe methods of cooking. And these toilet facilities too, we now have safe toilet that can even make that have biodigesters to give us gas at the end of the day. So to me, as he said, neither of them outweighs each other. They are both unique in their ways based on whoever is using them. So that is what I also have to say about it.
Okay. All right. Thank you. So I think, well, that was a good argument, and then for me, it depends. So you see, it depends on, and you see, you whatever you say to, you have to have evidence. As I said, we are scientists, and so if you would want to, okay, there are other research that prove that some of the intermediate technologies that we use are a bit harmful. There are research that have shown that the microwaves that we use, uh, too much of that emits radiations into the food that we eat. So in turn, people who use it for a long time tend to develop cancer. That is what the research have got. There was also a current research published in the University of Cape Coast that also shows that the fufu pounding machine, they detected a bit of metals in that in the product. That is it. On the other hand, there are others to that, other researches to that also shows that the traditional means of distilling, distillation, apetition or alcohol, also leaves contaminants in the product. You see, so it depends. Okay, it depends. As I said, it also depends on how well, who is also using it. That is what I think. And I think someone mentioned that if you want to use the mortar and pestle and you clean it well, I'm not sure you're going to have issues with bacterial or viral or whatever infecting, no, the fufu. For me, I prefer the mortar and pestle. I don't like the fufu machine. No, there's Mr. Bernard even says the texture is even not nice. So I don't like, but that is not my reason for saying that. It also depends on you how well and how careful you operate those machines. Okay. They are just there to help us live life well. They are just there to help us, what do you call it, have a good life and then improve upon productivity, as we said earlier. So whichever way we want to use it, it's okay. But well, let's hope that we can come up with more secure technologies that we can use. Okay, so that is intermediate and then traditional technology. So the intermediate is it's actually an improved version of the traditional technology. Okay, the traditional technology is the basic one, and then when we come to the intermediate one, it is the improved one, and it also relies on improves upon the weaknesses of the traditional technology. So when you see a typical intermediate technology, it is an improved version of the traditional one. And Madam Charity cited an example of the animal taxon. Okay, where they attach a wood to a cattle, and then the cattle will be what do you call it? They'll be pulling it through the soil to just make it soft. Now there are tractors and vehicles and heavy vehicles that does that. You understand? So that is an improvement upon the what do you call it? The animal taxon that was previously used. We get it. So it is an improvement upon the traditional technology. Now, not every technology can be what do you call it? Described as intermediate. Before something is described as intermediate, there are some conditions that particular technology should adhere to. One, it should be affordable in terms of capital. Okay, before an intermediate technology or a technology will be said to be an intermediate technology, one, it should be affordable. But you should ask yourself, how many of your colleagues or how many of your people can afford all this intermediate technology? Even in the rural areas where agriculture is ongoing, there has been a continuous effort to advise our farmers to go into advanced agricultural tools. How many of our farmers can afford those tools? No. Okay, but we are being told that before a technology will be an intermediate, it has to be affordable. Okay, that technology should also use locally available materials. So if you have a gadget, if you have an instrument, and that instrument cannot rely on locally manufactured materials to operate, then it's not an intermediate technology. Okay, it's not an intermediate technology. Now, one thing that you have to also look at and understand is the fact that based on geographical location, what might be an intermediate technology in Ghana will be a traditional technology outside Ghana. In Ghana, we were jubilating over 4G networks. But when you go to China, they are and those advanced technology. But bro, they are using 5G. Oh. So we are jubilating over 4G. But someone somewhere is even angry and looking pissed off with 5G. Okay? We are jubilating over certain minor technologies that we use. But when you go outside, that is, excuse me to say, trash to them. Okay, so based on geographical location, what might be an intermediate technology for you would be a traditional technology for someone. All right, so we shouldn't confuse ourselves with that. Okay, so an intermediate technology should be able to use your local materials effectively. If it does not do that, it is not an intermediate technology. And it also rely on renewable energy sources. It should rely on renewable energy sources and should have high potential for employment. Should have high potential for employment. This is a very important point because there has been instances where people are afraid that technology will take up their jobs. No. It should rather create more jobs for us. It should rather create more jobs for us. And that's basically would